Hey everybody, this is Bradley Bush with another algebra video for you. Today we're talking about scientific notation, and specifically we're going to work through an example where we change from decimal notation into scientific notation. The example we have is we have a number that's a fairly small number. It's 0.0000256, and our job is to change this from decimal notation, which it currently is in, to scientific notation. Well, first, why would we want to do this? Well, sometimes when we have really small numbers, or when we have really big numbers, we have a whole bunch of zeros that don't really need to be there, meaning they just take up a lot of space, and it's kind of inconvenient to write them like that. So we can take a really small number that has lots of zeros, or a really big number that has lots of zeros, and we can write it in a condensed version that still tells you what it is, but doesn't take up so much space. So this is how it works. The decimal, when we're moving the decimal to the left, we have a negative exponent. When we move it to the right, we have a positive exponent. So we first need to identify the first non-zero digit that we have. So if we're looking at this, we have a 0, 0, 0, 0. These are all zeros. And then finally, we have our first non-zero digit, which is 2. So we put our decimal just to the right. And then the rest of it we keep. So let's come down here because we have a little bit more space. So we have a decimal just to the right of the 2. So we can write this 2.56. And then to make the right side equal to the left side, we've got to move the decimal a little bit, right? So how far do we have to go? How many times to the left do we have to move it if we write it right after the 2? If we write the decimal right after the 2, how many times do we have to move the decimal to the left to get it back to where it was originally? Let's count. So we have 1, we have 2, 3, 4, 5. So we'd have to move it 5 times to the left to be where it was originally. So this becomes the question mark there. So 2.56 times 10 to the, we move it 5 times. That's where the 5 comes from. And the negative here is because we have to move it to the left to get it back to the original. So again, when you move the decimal to the left to get it back to the original, your exponent is negative. When you're moving to the right to get it back to the original, then it's positive. So we can now write our answer because our decimal version was given to us up top, 0.0000256, and the scientific notation we're going to write down here, which is 2.56 times 10 to the negative 5. Hope that was helpful, and thanks for watching.